I'm Sana Sethi, Program Officer, Blockchain for Impact. And yesterday, when I was thinking how to initiate the event, what should we talk about, I realized that we are just 2 days away from the Independence Day. And turns out everyone in this room is kind of chasing some kind of freedom. Not from the Britishers this time, but either from EC committees, IPO approvals, or that one email that is pending in your inbox that says that your review has been pending. So, and let's be honest, an idea in an institution rarely dies because it was a bad idea. It dies because it is stuck. Stuck in a form, stuck in a meeting, or behind someone that is traveling this month or week. So, while the country is out there celebrating the Independence Day, and we will all be celebrating, but these 2 days we will kind of chase a kind of freedom which is a little specific and for our medical institutes. So the independence that we give our medical institutes to kind of scale and innovation, scale and fund innovation. So that's the whole point of Medical College Incubation Center program. And it's not just any random program, but a real shot of giving medical institutions the independence so that you bring the research which is sitting in your lab to actual ecosystem. With that, please join in welcoming Dr. Sonalika Singh, Program Manager, Medical Innovation, BFI, for the welcome address.
Thank you, Sana. Good morning, everyone. Distinguished guests, speakers, experts, leaders, partners, partner medical colleges, and colleagues. I'm Dr. Sonalika Singh, Program Manager, Medical Innovation, and on behalf of Blockchain for Impact, it is my privilege to welcome each one of you to the two-day orientation for the Medical College Incubation Center program. Thank you for taking out time to join us as we embark on what we believe is an important step towards strengthening India's medical innovation ecosystem. Before we begin, I would like to briefly set the context for why we are here. Our medical colleges are at the heart of healthcare delivery, medical education, and research. Every day, clinicians and researchers encounter challenges that can potentially translate into new technologies, products, and solutions. However, the journey from identifying the problem to developing an idea, validating it, building a prototype, navigating all the regulatory pathways, and ultimately taking the solution to the patient is quite complex. It requires not only scientific and clinical expertise, but also mentorship, infrastructure, institutional support, industry engagement, and an enabling ecosystem. This is the gap that Medical College Incubation Center program seeks to address. And as the incubation centers begin their journey, it is important that all the center managers, coordinators, and all the stakeholders associated with the program have a shared understanding of program's vision, implementation approach, operational processes, and expected outcomes. And that is the purpose of these 2 days. This orientation is not only about introducing the program, it is an opportunity for each one of us to learn from established innovation ecosystem, share experiences, identify common challenges, explore their solutions, and build a network of institutions that can learn and grow together. Over the next 2 days, we'll discuss the key components of building and running an incubation center, which includes creating innovation pipeline, governance structures, startup support mechanisms, regulatory pathways, and strategies for fostering collaboration. We will also hear from experts and institutions with experience across different stages of innovation journey, from supporting research and early stage ideas to preclinical and clinical incubation, product development, commercialization, and industry engagement. Another important part of the program will be the Innovators Roundtable, where we move from listening to actively discussing the common challenges faced by innovators and institutions, and we hope to identify common challenges and their solutions, opportunities for collaboration, and mechanisms for better supporting startups. We have also planned a visit to M Pragati facility to witness the incubation and innovation support infrastructure and understand how different models can support prototyping, technology development, testing, and translation. This program will also provide a platform for all of us to learn from one another, exchange our experiences, and build partnerships. By the end of these 2 days, we hope that participants will have clear understanding of the program, Along with that, they'll be able to take away some key knowledge, new connections, build partnerships, and ideas that can be translated to solutions within their respective institutions. I encourage each one of you to actively participate in the discussions, ask questions, share your experiences, and make the most of the expertise gathered here. Once again, welcome to the orientation program. We look forward to 2 days of insightful discussions, connections, and shared learning. Thank you.
Thank you, Dr. Sonalika. Beautiful, beautiful start. Now I would like to call someone who has actually built institutions around it. And please welcome Professor Ashwini K. Agarwal, Dean R&D, IIT Delhi. Professor Agarwal holds Manish Singhal Chair at Department of Textile and Fiber Engineering with his research spanning across smart and intelligent materials, nanomaterials and advanced fiber technology. And he has experience in research and technology development and translating academic work into impact. And we are pleased to have him today. Professor Ashwini.
Good morning and welcome to IIT Delhi. It's a privilege to have such distinguished people on IIT campus, and especially the medical fraternity, which we hardly get, and we are really not used to having them here. We often visit hospitals to seek care, so that is normally our way of touch with the doctors. So welcome all of you here. This is a small presentation. I'll ask them to upload. So I'll take this opportunity. You may know about IIT Delhi quite a bit, but still I will take this opportunity to introduce IIT Delhi in brief to you, what we are, where we are today, and how we can collaborate and how we can come together to solve problems which are very typical of medical colleges and the patients whom we are serving. So IIT Delhi was established in 1961, and since then we have been growing. Both BTech, MTech, and PhD programs were introduced in the next few years of this establishment. And in 2021 or 22, we got the tag of Institute of Eminence from the Government of India. Next slide. Today we have 3 campuses. So this is the Haushaus campus where you are sitting today. And we have Sonipat campus, which is about 40 kilometers from here. And then we have, last 3 years, we have opened Abu Dhabi campus. So it's a IIT Delhi Abu Dhabi campus, which is completely funded by Abu Dhabi government. And now it's in transit. Right now it's a transit campus, and we have started few BTech programs and MTech programs and PhD programs there. And slowly we have identified now land there, and the whole campus will be built, which will be IIT Delhi Abu Dhabi campus. So this year, the first batch has graduated from there. Next slide. So we have created over time buildings, which are, some of them are old, some of them are new. This one is a new building, RNI Park, which you are right now sitting. Next slide. So if you look at what IIT Delhi is in global positioning, so we are, if you look at the university ranking worldwide, so we are 118 as a university, but we are not really a typical university. We are more of a science and engineering college, right? Science and Engineering Institute. And if you look at in science and engineering, we are number 36 in the world. Now that places us at a very important position, and out of the number of academic units we have, 5 of them are ranked among first 50 in the world. We lose because of international presence on the campus and the international faculty, which we don't have much of it. Otherwise, our all citation scores, etc., are way up in connection or in relation to the other institutes. Next slide. So these are the departments which we have. We have about 31 academic units. So you look at any engineering, and almost all of them are here, from computer science to energy science, mechanical, electrical, chemical design. So we have a department of design now, which helps in designing the prototypes and the ergonomics of a product, or the usability of it, or how the people perceive and things like that. Applied mechanics, biochemical engineering, and civil engineering, material science, textile and fiber engineering is the only department in IT Delhi is where no other department, no such departments in any other IT. Physics, chemistry, mathematics are general. Humanities and social science is expanding. We are getting into cognitive sciences now. We are going to establish a program in cognitive science. Then we have a management studies, and this management school right now is number 4 in the country after ABC. I am ABC. We are number 4. Next slide. So we have certain centers like applied research in electronics, biomedical engineering, automotive, optics, photonics, sciences. So things which are in orange color are those which can be very relevant to people who are here. The Sense Center makes all kinds of sensors, and optics and photonics center is involved in quantum as well as normal optics and laser guiding mechanism and things like that. So we also work in atmospheric sciences, transport and injury prevention is another area which is very, very active, and we have a lot of international collaboration in injury prevention, how the roads and traffic should be, how the mass transportation should be. Rural development technology, value education, educational technology. We have a school of biological sciences which really work on the core issues of biology. Artificial intelligence, we have a school of which is Yardi School, very well funded. We have a department of policy, which is public policy, School of Public Policy. This is where now again it is funded by Tata Trust right now, and a lot of major projects are being taken on policy decisions nationally and internationally. Those research are going on, and there are others. Next slide. So currently we have about 12,500 students on the campus, and about 600 and this number is a little old, 680 faculty members are there today. So you can think about it's a very large institute with very large number of faculty members working in different domains. And almost out of the number of 12,000 students, we have almost 3,800 students which are just doing PhD at any given point of time. So there's a very large research base. So today, at one point of time, we were known more for a UG education. Now our position is actually more from our research and citations which we get out of it. Annually, we file, I think the number is wrong, we're almost filing 1 patent a day, and almost producing 4,000 research papers in international journals every year. Next. Our startup system has been one of the oldest in the country, and we have at any point 150 companies which are incubated on the campus. This building itself is an incubation center, one wing of it, and we give space to incubators. We also have in Sonipat campus Atal Business Incubation Center. We have a specially biotechnology business incubation facility by BFI, and also supported by DBT. Next slide. The research facilities and the analytical facilities are quite a bit on the campus. I would be very happy to tell you that almost we have invested about 400 crores of rupees just establishing high-end facilities. So today we have Param Pragya, which was just recently inaugurated by Prime Minister of India, which is the high performance computing in AI. So on the educational front, we have one of the strongest computer today for AI work, which is in the educational domain. We have a nano scale research facility, which is NRF. Prakriti, we were talking about it, and I think we'll talk more about it. It is funded by ICMR. And now BFI has also joined hands in promoting the work in Prakriti. And we have central research facilities which is occupying almost all kinds of instruments which you can think of. Next slide. So these are some of the things, some of the facilities which you would find useful. And I'm not just listed all of them, some of them are there. You can go to the website and find more. Next. So today we have connections with about 80 international MOUs which we have, which are active MOUs, and some national 40 about are there. And we are spread all across the globe with these MOUs. Next. We are actually running joint PhD programs, which means the degree is given both by IT Delhi and the research institution abroad, university abroad. So very recently something which may interest you is the University of Sorbonne, which has a very strong health program. We are starting a joint master's and a joint PhD program in medical sciences or related areas. NYCU, we have a semiconductor devices joint PhD program, and University of Queensland, we have in all areas. We give almost 159 students have now graduated from University of Queensland and IIT Delhi joint campus. Next. So these are just different universities in which we had. So we have a joint seed research program where we fund our research, our side of research to our faculty members, and the other institution does the same for their faculty, and together they carry out a project. So it's seed funding, which means one has to then grow into a larger project. So these kind of things we do not only with international universities, also with national universities. So I would welcome you to join hands for a joint seed program wherever you feel correct and appropriate. Next slide. So these are some of the institutions with which we had joint seed program within the country. And with Ashoka, All Indian Institute of Medical Science, we have a very strong relationship. Almost 3 different programs have happened with AIMS. Next slide. So these are health tech collaborators whom we have been working with. You can see some of the names which are quite well known. Next slide. So these are 4 pillars on which health tech work is being promoted at IIT Delhi. Please click. So one is personalized medicine, which is obviously becoming very important today. Smart wearables, medical implants, and diagnostics and medical data management. So these are 4 verticals on which we work, and we would definitely like to collaborate with you, with your professors and other colleagues to take these things forwards. So as we were just discussing, I mean, medical profession is one which is a user for us, right, for any technology. So you are the one who has to give us the problem statement, and you are the one who has to make sure that whether we have succeeded in solving the problem or not. So it's very important that we tie it together. Next slide. Next slide. So in personalized precision medicine and functional omics, these are some of the areas in which IIT Delhi has been working. I can share this information later on. Next slide. Smart wearables, we are doing a lot of work. Even in the Department of Textile Technology, Textile and Fiber Engineering, we have various ways in which we can collect data from human, either sports or sports injury prevention, rehabilitation, and things like that. Next slide. So sensing, instrumentation, biomechanics, product development. Please continue. Next slide. Next. So these are just some of the. So we are also there's a very strong program on assistive devices, especially for people with special abilities. There are various programs which are now internationally also known. Next slide. In implants, a lot of work has happened. Professor Dinesh Kanansundaram may be able to shed more light if you talk to him. So various things are being done. Next slide. These are in the area of diagnostics and detection technology. I'm just giving some examples. It's not exhaustive list from any angle, but just to give you a kind of a flavor what IIT Delhi has a capability of doing, so that you can. So it's not purely that we keep doing just mechanical or chemical engineering and not work on anything. We really worry about wherever technologies are going and how they have to go. Next. So these are AI integrated systems and digital healthcare, which is becoming very, very important nowadays. Next. So some of the impactful technologies which have come out, randomly they have been put. So there are soluble micro devices for collecting bio environment from the intestine. There are rehabilitating devices, antimicrobial polymers, materials of different kinds, digital health, tactile diagrams, which is assistive device. This tactile diagrams are for actually STEM students, STEM students. The reason is normally you have braille which can only tell you about the text, but if you want to show a diagram to a person who is blind, then you have to have a different technology so that they can identify what is what. So with research, we have come out with very low cost books which can show you diagrams and explain you science and engineering in diagrams to a person with a difficulty in seeing. Next slide. These are some of the other examples. Next slide. So this is the last but most important slide that we have realized at IIT Delhi that we cannot work alone, in especially medtech area, and we need to really strengthen the collaboration. While we have 3 departments who are purely working on medical and related areas and biotechnology areas, and almost all departments, something or the else is going on which is associated with medical. Because there are a lot of people who are in electronics and electrical who keep making devices which can collect, transmit data, etc., or build devices, mechanical engineering where you can fabricate very precise instruments. So all these things can be done here at IIT Delhi. So you're most welcome to explore with BFI as well as Empragati and other departments and approach and tie up. So with this, thank you very much.
Thank you, Professor Ashwini. May I request you please be here? And I request Dr. Gaurav Singh, our CEO of BFI, to kindly felicitate Professor Agarwal as a token of our appreciation. Can you please move? So now we come to a session that many of us will probably relate to. So when you are developing a medical device, there are always questions, some technical, some regulatory, some clinical, and some are the questions like, wait, how does this even actually work? So, and these are the questions that sometimes we are hesitate to ask, and these are the questions that we often Google at 1 a.m. in the night. So to tackle all these questions, our next speaker is here to tackle all these questions, and our speaker brings together 2 perspectives that are extremely relevant to what we discussed today: clinical practice and innovation in healthcare. And we are pleased to have Dr. Sanjay Bihari, a neurosurgeon and director of Sri Chitra Tribunal Institute for Medical Sciences and Technology, an institute of national importance, having a long-standing legacy of bringing together medical sciences and biomedical technology together. With that, please join me in welcoming Dr. Bihari to deliver a keynote on the session titled Biomedical Device Development, Answers to Stupid Questions that I always wanted to know but I was too embarrassed to ask. We'll take a moment in the meantime Dr. Bihari is getting his caller mic done.
Yeah. आपको उसमें चेंज करना पड़ेगा वो जो उस पर मुझे चेंज करना पड़ेगा आपको जो उसमें कनेक्टर में चेंज करना पड़ेगा मतलब इसमें चेंज करना पड़ेगा.
So we might take 2 more minutes because we see a technical glitch here.
नहीं कनेक्टर नहीं है वो इसको यहाँ पे कनेक्ट करना होता है ना तो ऑटोमेटिक आना चाहिए तो एप्पल है उसको करके चलो ओके अच्छा आपके पास में कोई वो है आपको सुनो दोस्तों
आपको USB-C है ऐसे कैसे आप दूसरा कर लो मैं एडजस्ट कर लूँ इसको वो करो बंद इसको कैसे बंद करें ये क्यों ऐसे क्यों आ रहा है ये आपको कोई और नहीं है केबल एचडीएमआई में हाँ ये काम करो ठीक है आप USB-C ड्राइव है
Hi everyone. So in the meantime, presentation is loading up. I would request Dr. Gaurav to come for a special address. And for him, I would say that every good ecosystem needs someone who backs it before it becomes cool and keeps on backing it. So please welcome Dr. Gaurav for the keynote address.
Thank you, sir. It's always nice to fill in for a technical glitch, and it's my first time though, but I'll try. So, welcome everyone, and it's a very glad moment for actually me as a doctor, because 2 years back we had this vision that why should only engineers innovate and why should doctors be left behind? So we export a lot of medical science graduates outside India, but we import a lot of medtech devices. And the vision was always how can we change this fact? With that vision, MCIC program, Medical College Incubation Center program was launched last year. We got many applications, out of which 10 medical colleges were selected, and in future we hope to see many more also. So in this whole exercise, we are funding medical colleges to start an incubation center. The concept of incubation center is very new for medical college, but it is one of the criteria to jump up the rankings for the engineering colleges. And very soon I think it will also be implemented in medical college for the same purpose, but at least it's something of a start. So I wonder, when I was doing my MBBS, then I did my MD in psychiatry, no one ever told me, or there was not a single chapter in my curriculum which corresponded to how does a medical device work. They will tell us that okay, these are the symptoms, these are the devices to measure those symptoms, but how is that device functioning? I think most of us as a doctor are utterly ignorant about that fact. As a hospital administrator, I can tell you the only thing that happens is whenever a device goes bad is called the biomedical engineer. And whatever he tells becomes the gospel because we have no clue. The same is true for the device getting bad. We have to condemn certain devices, we have to give AMC, CMC of certain devices, just on the behest that we have no knowledge about how a medical device work. We are mostly on the mercy of others to understand this whole process. Also, a revelation that I had while we were traveling across length and breadth of the country, visiting many engineering colleges, and by the way, then it was my first time that I came to know that medtech is also a domain that only engineer handles, and there are no doctors there present most of the time. But I was astonished to see young engineers working on many solutions without any help from medical doctors. And because of that, they were not able to understand a simple concept of need and demand. They saw a clinical question and they started to find answer for that, not even understanding that this is actually not sellable. If to a pediatrician I am trying to sell a device that sees what is the type of jaundice or what is the skin color of jaundice that my device can detect, he does not need it because he has eyes to do so. So the context and the medical supervision that medtech devices need is very premature in this country. This concept of incubation center is also very premature in this country. There are certain incubation centers which are functioning very well in medical colleges. I think St. John's is one of them. Then we also have some other places too, but overall it is very rudimentary. If we can develop this incubation center and the culture within medical students to start questioning. The brightest students of our young minds either go to MBBS or they go to engineering. Most of the time, 70% is true for the brightest mind that come there. But engineering students do a lot of innovation. They spend a lot of time in those innovations. They also try to actually form companies, become entrepreneurs. But on the medical side, it is highly lacking. It was one of the vision of our founders that how can we have this concept that big medtech companies are visiting medical colleges campus for recruitment, like they do in engineering colleges. So with this, I welcome you all. I hope that this initiative will kindle a lot of innovation inside medical colleges campuses. And today we have many prominent speakers. They will guide you about how medical devices and how does medical innovation works. My request to all of you is ask as many questions as possible, because you have to replicate the same things in your own centers, in your own medical college incubator centers. BFI is always there to help you, and we hope that you gain a lot from this studio workshop. Thank you.
Thank you, Dr. Gaurav, for the usual honesty over the keynote. Now, please welcome Dr. Sanjay Bihari, Director, Sri Chitra Triennial Institute of Medical Sciences, to talk about the questions that we usually think about at 1 a.m. in the night.
Hello. Hello. Yeah. So I'm sorry for the glitch. It's an honor and privilege for me to be here, and I'd like to share with you my journey from many things, from being a pure clinician to being an administrator to being an editor to being a researcher to being an administrator to now looking after many areas of national health policies. But the interesting thing is that we have so many people here who we meet so often, and it's our checkered lines of fate. When you look at their hand, it has many lines, right? And we have our checkered lines of fate converging and diverging, looking for a point of intersection. And this is one area where science, engineering, technology, administration, finance, everything converges in one particular spot. So I'd like to just talk about biomedical device development, answers that I always wish to know to stupid questions that I felt too embarrassed to ask. And most of us are very embarrassed to ask these questions, but these are all very important questions which actually need to be asked. So I was a very busy neurosurgeon for nearly 30 years as head of neurosurgery of SGPGI Lucknow, attending to patients, operating, teaching, extensively traveling almost every year, almost 5, 7, 10 countries. I was practically applying to surgery what I had slowly learned over the years in a very busy center. Life was satisfying, gratifying, and comfortable. And Bhagavad Gita, chapter 13, text 23 says, Udrashta numantacha bharta bhokta maheshwaraha paramatmaiti chap yukto dehe asmin purusha para. What it means is, yet in this body there is a transcendental enjoyer who is the Lord, the supreme proprietor, a super soul who exists as the overseer and the permitter. So often we don't have control over what we do. Destiny takes us to areas where we never imagined we would actually go to. So there is a divine beckoning that we all need to follow. And so I entered the fascinating world of medical device development as a member of the fraternity of Sri Chitra Triennial Institute for Medical Sciences and Technology. It's an institute of national importance. It's a statutory body. It is the only medical college under the Department of Science and Technology. And just to give you some idea about its work, for 40 years they're making medical devices, and like the Chitra heart valve has been implanted in 200,000 patients. In the last 4 years, we have translated 23 devices and commercialized 6 of them. We earned a revenue of almost 2 to 3 crores on medical devices. The Chitra heart valve has been implanted in 200,000 patients. And the ventriculoperitoneal shunt, now with HLL, it's been implanted in 4,000 patients. The intrauterine contraceptive device, which is prevalent all over the country, was the Chitra technology. We just translated deep brain stimulator. With spinal cord stimulator is just going to be translated, and fibrin glue has just been translated. So many things have actually. So this is basically focused on in vivo deep tech devices. So now I'm the director of Sri Chitra. So secure and proud is the word it acknowledged, sat the pompous man on his wondrous knowledge. Alas, in his moment of success, in a new world to which he had access, came the grim thought that he knew not, that he knew not. So had I was in charge of the entire biomedical technology wing of the institute and the public health wing of the institute along with the hospital, and I had absolutely no idea of what this particular wing was all about. I had no idea about how engineers think. I had no idea how scientists think, how administrators think, how financiers think. So being a part of the fraternity of Sri Chitra and the ecosystem of biomedical device development, there were questions I desperately wanted the answers to, but was too scared to ask. I'm the director, how can I ask these stupid questions? Right? So, luckily being the director gives me, because of the chair I sit on, the ability to mask to a little extent my own stupidity and ignorance in the presence of extremely intelligent and committed people whom I have the privilege of meeting daily. So let me share the answer that I have quietly learned along the way to those stupid questions that I always yearn to ask. Why do I use this word fascinating for medical tech? You know, it's fascinating because the individuals are willing to spend a dream working on something not knowing where the next step of funding is coming from. They don't even know. They've never entered another ecosystem and then they're pursuing medical devices. And the third thing is, there will be people like me who have the capability to block every step of medical device development in one signature that I do, and yet they plod on and yet they plod on. It's a fascinating world of medical device development. So, and it is also fascinating. Another point that is very fascinating, and it actually reflects on all of you, that the end users of this dream, the doctors, have no idea of the dream or actually the process which is involved in it. This is absolutely fascinating to me. I can't imagine. So sorry. I'm sorry, this won't work. But just to tell you that when you're an operations theater, you think that medical device is some exotic thing that you need to develop. It's not like that. Everything that you see, this is not neurosurgery. Every aspect you see encounter on a daily basis is a medical device. Whether it's trolley, bed, drip set, saline drip set, IV cannula, apparel, and antibiotic. And each one of them has gone through exactly the same process till it has been commercialized. The only thing is you don't know about it. So, I mean, there's a huge scope for all of us to actually take it further. So, when you actually organize life cycle of an organization, so there's a prophet. So the prophet actually is the visionary who starts a new thing. And then there's a builder who plods on and takes it to the next level. And then there's an explorer who tries new things with the idea of the visionary of the prophet is given. And then there is a synergist who provides the energy to take this idea forward. And then there is an administrator who has to make rules and regulations as the organization grows. And then there comes a bureaucrat who has to put in all checks and balances so people start using the system to their own advantage. And then the system collapses till another prophet comes in and takes it forward. So right now we are at different stages of this organizational life cycle. And this medtech for you is a new thing, but it's been going on for almost 50 years in this country. So 15 questions and answers I like to ask. First is a very simple fundamental question. What is the difference between biomedical sciences, biomedical technology, and biotechnology? A very fundamental question, but most of us don't know the answer to. So, as a biomedical scientist, you focus more on research and treatment of disease. Okay. As a biomedical technologist, you are researching with developing equipment and methodologies used to treat diseases. So you're focusing on technology. And as a biotechnologist, you're actually involved with production of raw materials with the aid of living organisms. So there is a fundamental difference between all these things, and to be very honest with you, I had no idea about it when I actually started my administration. What is the difference between discovery, invention, and innovation? How many of you know this? What is the difference between discovery, invention, and innovation? So a discovery is something which has not been found before. but it is already existing for a long time. That's discovery. And invention is something totally new that is created from one's own ideas. And innovation is the practical implementation of an invention, which means that once it is useful for bringing about a meaningful impact in somebody's daily life, market, or society, then from an invention it becomes an innovation. So, what are the steps in biomedical device development and translation? Is the next step. So everybody thinks you make a device and take it and start using on your patients. That's some myth. So first of all, you start with an idea, and then that idea becomes a prototype. And between this idea and prototype is the proof of concept, where there is one word which many of you have not heard of, and that word is epiphany. Epiphany actually means that you are focusing on your dream and an idea to the expense of everything else. You forget about everything, you forget about your monetary benefits, your financial benefits, your positions, everything, and just focus on an idea and take it to a prototype level. That's epiphany. Many of us actually are not succeeding simply because from idea to prototype, this particular step, which is epiphany, which involves a lot of self-sacrifice, is not really happening. Then once it comes to a prototype level, then you must understand one small thing about medical devices. You cannot just start using for your patients. And if you already be done with the industry which will scale up the device, please remember this. Whatever tests you do are of no relevance to the systems till you do it with the actual companies which are scaling out your device. And then you come to the preclinical evaluation phase, where you actually look at its physicochemical properties, look at how it is, look at its immunological properties, look at its biological properties, and then after that you actually go for ethical clearance, and then you go for small animal testing, large animal testing, and after the large animal testing, then you apply for clinical trial permission. And all the data which comes from your preclinical evaluation actually goes to CDSCO, which is the organization which looks at your data and then says, okay, fine, this can be used on human beings and it can get tested with human beings. And then you apply to Indian Council of Medical Research to actually go for multi-center trial and multi-center trial. And after these trials and the evaluation by the Indian Council of Medical Research, then only you can bring this device to market. And then once the device comes to market, it's not so simple, because there is another agency known as Material Vigilance. And Shishitra is the National Collaborating Agency for Material Vigilance, which means that the safety, the design, the iterations, they will all be evaluated again. And based on those evaluations, you can make new models, you can continue with the device, or you have to draw the device. So this is the entire life cycle of a device which you need to know about. So most of you will know about translation. Then you come to proof of concept phase, where with the industry, you develop the device, you standardize the device. And that is translation readiness level 4 and 5. Then you have a preclinical evaluation phase, which is translation level 6, which is the preclinical evaluation phase. And then you come to technology transfer, which is translation readiness level 7. And then you do a clinical evaluation, which is translation readiness level 8. And then you do a commercialization, which is translation readiness level 9. And no industry will take your device at the prototype level. Most of them will not. They will want you to come to at least 6 or 7 before they actually allow you to take it up. So just, I won't go to this. So we have several devices, these deep brain stimulation, electrocorticography, many spinal implants, We are using all these 3D printing. Many of these things have been done. But you must understand that, so there was this Padma Shri Ananda Shankar Jayant, her troupe had come to Trivandrum, and I took this photograph. And suddenly this photograph became very special because this was a long exposure, and what happened was that these, sorry, this is not working. This is not working. So you see that there's a double exposure to some of them, and because of this double exposure, this has become a special painting, special photograph. So like that, it's a very dynamic process. It requires cooperation, it requires cohesion. Now, what is this low-tech, high-tech, and deep-tech devices you need to know about this? So, well, low-tech devices are simple, easily replicable. Okay, easily replicable. They are used in everyday life. They meet basic needs. And high-tech devices are those which have advanced features. They have capabilities focused on specific industry issues. And you have a deep-tech device which require a deep thought. Now, what would you prefer? Would you prefer to make a low-tech device or a high-tech device or a deep-tech device? It's a bit of all. If you make a low-tech device, it will be translated fast. But the disadvantage of a low-tech device is somebody will just replicate it, make a small iteration, and immediately copy it and use it. And your device will no longer be relevant over a long-term basis. When you make a deep-tech device, it takes a long time. But having made that deep-tech device, it will continue for a pretty long time. So this is the difference between low-tech, high-tech, and a deep-tech device. What are the classes of devices and the average time taken for their commercialization is something which most doctors don't understand. So you have class A, which are low-tech devices like wheelchairs, walking aids, stethoscopes, incision drapes, dental patient chairs. They are class A devices, low risk levels. Then you have class B devices which involve low to medium risk, like you have hearing aids, tubings intended for use with infusion pumps, devices for storage of organs of transplantation, tracheal tubes. So they are class B devices, they are low to medium risk. Class C are those which will be used for the patients, like urethral catheters, like lung ventilators, like dressings, but then you discard them over a period of time. And then there are class D devices which are high risk, which will be kept there for a long time. They are high risk devices like your heart stent device, or intra-aortic balloon pumps, or spinal implants, and or prosthetic heart valves, or central venous catheters. They will be kept in the patient for a longer time. So why aren't we, when we say that, oh, we made this device, we made this device, actually the device is made when it is used on a patient. Before that, it is of no value, to be very honest with you. For a very fast-track device like in COVID, then it was 1 year. If it is a short term, it is 1 to 3 years. If it's a medium term, it takes 4 to 6 years. But when it's a deep tech device, it takes 7 to 10 years to actually translate a device, and takes even longer to actually commercialize a device. Translate means that you are giving it to the industry to co-partner with the industry. And commercialize means it is actually being placed in the market for use on a patient. So now there are two valleys of death. What are these valleys of death? So what happens is, you have a fantastic idea. You have the epiphany and the energy to work on it. You have made a fantastic prototype. However, the industry says, we don't want it. It requires too much of expense. Sometimes they will say, it is not commercially viable. Like for our ventriculoperitoneal shunt system, they said, it's not commercially viable. We don't actually want it. And then we have to really push them to and make them understand it's a life-saving equipment. It's not about profit. You have to work on it. So the first value of death is, from your prototype to the industry actually taking it forwards, is the first value of death. If you can overcome that first value of death, then you come to the second value of death, which is, you have done the testing, you have done all the iterations, you have done the technology transfer, you have a product, you have actually taken all the accreditation also. CDSU has also approved it. but the doctor says, I won't use it for my patients. I will only use a foreign device. And that's again the second value of death when all entrepreneurs fail. So you must remember these two values of death, and we are all responsible for making sure that our Indian device industry does not encounter these two values of death, which are actually the bane for medical device development. A little bit about patents and intellectual property, which most doctors know nothing about. So what is a patent? It's a protection of business or an intellectual asset. So you can not only patent a device, I also patent trade secrets, industrial designs, even processes you can patent. How a particular device can be made can be patented. You can patent trademarks, copyrights, new varieties of plants, layout of integrated circuits. All of them can be patented. The biggest point that I would like to tell you is that patents does not involve making of a device. It's your idea which is patented. So please remember that if you have actually made a particular product, do not publish it. All doctors are very fond of publishing. Chalo, publish karo, publish karo. No. To keep it secret, patent it. Once you get a patent registration, then only you can actually take it forwards and reveal it. Because if you have published it, then that is no longer yours. Anyone else can use it. So please remember this very important aspect. Then it's a statutory right to the inventor by the government. So it's only for a limited period, and there has to be a sufficient disclosure made. So which means that many products you don't want to patent. Like for example, Coca-Cola does not want to patent its formula. Why? Because it wants to protect it. Only 3 people know in the world. So they don't patent it. Because if you send it for patenting, you have to completely disclose it, and on the medical device, their website, the entire patent will be exhibited. Your entire process will be exhibited. You will get credit for it, but everybody will know about it. And many people don't want that to happen. So many people don't want to patent it. Other people who don't want to patent it, somebody who actually uses the device for public health, they will say, if I patent, then one person gets all the commercial advantages of that patent. And I want to leave it open. So I want to make it into an open source system. And therefore you won't want to patent it. You say, I make it into an open source system for everybody to use. So one important point is that it has a territorial right, which means that a third party cannot manufacture, use, offer for sale, import, license, publish without authorization from you. However, there's very important point that you need to know that it is country specific. So if you are patenting in India, then this patent will not work in the US. And another person in the US has complete freedom to patent it, although the idea is yours. But then the point is, if it's registered in your name, that's very difficult for them to, you can actually fight in the court against that person. And when to file? Okay, as soon as the product has developed to a small extent, because any delay, other invention may take advantage of priority. You cannot publish prior to the patent, and registration of communication may compromise the novelty of the product and somebody can copy it. Then for international patents, you file patent applications. This is, as I told you, country specific. It comes in about 30 to 31 months. But the important thing in patents is international. You don't waste so much of money on having an international patent. You only have international patents for those products which you want to sell in that particular country. There is no point in your wasting time on more and more and money on more and more international patents when you actually don't want to do business in that country. It's not only for your prestige. And the biggest thing which I'll tell you in medical device development, what is the most important thing I have to remember when I'm flying a plane? I have to ensure that the number of my landings must be equal to by the number of my takeoffs, right? Even if there is one difference, it's gone, right? However, in medical devices, the best translation rate is 30%. And usually anybody who claims success for a commercialization level, the translation rate is 3%. It's a real pathetic number. And simply because the end users who are doctors should actually get involved with the engineers and scientists to make sure that they are giving the real information, first-hand information, which is responsible for the making of the device. Because the second-handedness of the information which you give is responsible for its mediocrity. If you're reading a book, it's not first-handed information. If you are seeing a movie, it's not first-handed information. It's still second-handed. If you're listening to me, it's still second-handed information. The first-hand information is what you do yourself, and that's very important for all of us now. So after prototype development, how does one upscale and test devices? So you do a medical device evaluation, you do a biological, physicochemical, preclinical animal model testing, you can do mechanical and calibration of the particular device. And so for example, we made this drug-eluting ceramic composite, hydroxyapatite ceramic composite for osteomyelitis. This is drug-eluting. And we had to do all these testings. We had to do electron microscopy, scanning electron microscopy. We had to do a lot of biomaterial testing and all those things. Then how can we perform technology transfer is the next step. So when you look at this, it's not like you can just call a company and say, hey, take this device when you're in India. What you have to do is, you have to decide its technology readiness level. After you have decided its technology readiness level, you call for expression of interest so that every company gets equal share. It's like a tender. You can't just go to a company and say, I want to buy your machine. You have to give an expression of interest. Then you identify potential industrial partners. Then your technology transfer committee identifies appropriate industrial partner based on how much money you are getting, or what the level of that industry partner is, whether the industry partner is actually capable of taking your device forwards. And then the terms and conditions are decided, and post-transfer testing and support has to be done by you. So these are important aspects that you need to look at. Now, just to take a break from all this heavy stuff, I'm full of ideas. Everyone asks this question. Why don't they lead to actual innovations and discoveries? So this is probably the interval of my talk. So then, one is that I talked about epiphany. There's one important thing, that 25% of job successes are actually predicted by, your intelligent quotient. Almost 80% is by your emotional quotient. And most of us, at some point, become angry, become impatient. We don't want to actually sustain ourselves through the entire process. The second important thing is, I'm sorry, this is gone, that there's some issue there in the computer. So this is an SGPGI. So both these blue bulls were sitting right opposite each other in this photograph. So the reason, there is a yin and a yang involved. We are not comfortable with many people. We only seek people who we are comfortable with. We will not seek, for example, a scientist or an engineer or an administrative officer, because we are not comfortable. As a doctor, we'll only go to a doctor in a party. Okay, it's like a done thing. We are so focused on only staying with people we are comfortable with that we just don't want to get into new areas. That's the next important thing. Then another important thing is that we have to focus on diversity. This is teamwork. And what we say is that a director will tell everybody, we need to focus on diversity. I want you to hire more people who look different but think just like me. That's a very important thing which is coming there. Another very important thing which is, I think, is a very, very important aspect, which is, just read this. So the spider says, excuse me a second, I want to check how many hits I've got on my website. And, we have different languages. Like a spine surgeon who's a neurosurgeon and a spine surgeon who's an orthopedic surgeon will have completely different languages. The first time I heard a spinal surgeon and he said sagittal balance, I said, hey, in 20 years of spine surgery, I've never heard of this word sagittal balance. So this is a very important thing. We have to develop a vocabulary which people from other fields actually understand. And that's a very important aspect. And finally comes this very important point. So this guy says, well, to be perfectly honest, in my humble opinion, of course, without offending anyone who has a different point of view, but also by looking into this matter with an alternative perspective and without being condemning of one's views, yet still considering each and every person's valid opinion, I honestly believe that I completely forgot what I was going to say. So this is a very, very important aspect, that you actually become so involved in this whole mess that you actually forget what your final destination was. So these are some important aspects. So now coming back to business, what are the major forms of institutional industry cooperation possible? What are the licensing models? The first of them is commercial partner upstream licensing agreement. This is the first model. What does it mean? Industry purchases the prototype with commitment to devote resources and share risk for future development. So it takes your prototype and takes it forwards. That is the first thing. The second is a quid pro quo agreement, which means the industry institutional co-development occurs. That's the second part, the second model. The third is the industry demand agreements, where the industry makes a demand and you make the device for the particular industry. And the fourth is in licensing of a component technology of material transfer agreement, that there is one particular patent technology, there is one particular part of the machine that you are interested in making, or one particular material that you have with you as a patent that you actually want to work in. The most important thing which everybody in India forgets to do, every hospital, this is a big issue, is documentation. Before you take anything to CDSCO, they will require very meticulous documentation, and 80% of us don't even bother about documentation. We don't even look at the patients we have operated and making a documentation of that. And this is very, very important, that not only for medical errors reduction, but also for any device which goes to an accreditation agency, you need to have absolute documentation. And before you go for union multicentric trial, you have to have CDSCO actually focusing on clinical assessment, the data collection, and they will look at all your data, and then based on the data, small animal data, large animal data, physicochemical data, and all of them has to be assigned by an accredited testing agency. So Sri Chitra has an international agency, COFRAC, which actually accredits it almost on every 5 years. And every year they will come, their inspectors will come and look at our thing. And therefore, whenever we test something, then it goes anywhere, you can use it anywhere internationally. So these are very, very important aspects that, and when you're doing these human trials, why is it so expensive? Because you need insurance cover for it. Without insurance cover, you cannot do it. That's why when you just say, oh, I open an incision and put my implant, which I have made, and I put it in the patient and it worked very well, you are asking for real trouble. Somebody is going to really cause problems for you one day. So what's a startup and Section 8 company? I think most of you know about it, but I just wanted to tell you one small thing about startup, that it's basically, the actual definition is that the total annual turnover should not be more than 25 crores in the preceding financial year. And it's not only involves, we have incubation centers, you all are part of an incubation center. Please understand that the youngster who comes to you is not only making a medical device. The youngster who's coming to you has to be guided in team hiring, working capital, legal and consultancy fees, raw material and equipment, licensing and certification, marketing and sales, office space and administrative expenses, and of course, finally, the prototype creation. So please understand that when you are part of this ecosystem, you have to have all these things built into your incubation center. So this is a very, very important aspect. And of course, Section 8 company has tax advantages. There is no minimum capital. There is credibility is very important because they will look at a lot of your things, but then there is a limited liability. Like for example, they understand that as a Section 8 companies, you will be failing. And if you are failing, then your personal assets are not going to be compromised. So if you have a house, that personal asset is not going to be compromised. That's a very important aspect of a Section 8 company. So please understand what this importance of Section 8 company is. But for doctors and ICMR scientists, You are not allowed right now to make personal Section 8 companies. And we are trying to, Sri Chitra is trying to bring out a white paper which we want to give to the government of India, where we say that let's have doctors also with some checks and balances actually be responsible for Section 8 companies, so that the end users can actually come in the making of the biomedical devices. What are the ways of funding of biomedical devices which are possible? So one is angel investors. What they have done is, they have already made biomedical devices, they have translated, commercialized them, they have been a huge success, and they want to pump in a part of their money into making of biomedical devices. The second are venture capital funds. So there are some people who are adventurous. They will say, okay, let's take these 4 startups and give them. Either we will take equity, means shares, or we will take, or we'll give them some loan. But at any given point of time, they can pull out. So they are venture capitalists. Then there are non-convertible venture debt bonds. They will give you debts, but this will not be a part of equity. This is a very important aspect. Then there are accelerators and incubators. So every institution, IIT Delhi, IIT Chennai, Sri Chitra, every place has incubators where startups come and actually help. There are family offices. For example, Wipro might want to support some startup companies. You have banks which give a loan on collaterals. You have crowdfunding. All of you can decide to fund me. And whenever I am successful, then I am distributing my money to all of you. That's crowdfunding. You can also get into that. And you can have revenue-based funding, that you give revenue to somebody for one particular aspect, maybe advertisement, for scaling up, for design iteration, and then you get it back. So these are models of funding which every company wants. And then comes a very important point. What are some Government of India initiatives to secure grants? In the last, the medical device policy came about 3 years ago, and there has been a revolution in medical devices in the country. And government has actually earmarked almost 2 lakh crores, 200,000 crores. You can't even, I don't even know the number of zeros there, to be spent in 2 years on our indigenous technology development, including medtech device development. And I'd like to tell you some of these Government of India initiatives on this. So you can have extramural research funds, you can have grants from various scientific organizations like DST, DBT, ICMR, centers of excellence. You can have industry who has to give funds. CSR means corporate social responsibility. Every industry worth its name has to give 10% of its profit earned to some other industry, hospital or something for them. And then of course training program that you run can also earn you revenues. You have all the startups. You can have Startup India Seed Fund Scheme. You have Nidhi Prayas by the Department of Science and Technology. You have TimeIt from Sri Chitra, which any startup company can join. You have state nodal agencies, like in Kerala, you have this Kerala Startup Mission. So you can actually go to them and get funds for your organization. You have BIRAC Seed Fund Scheme. You have to DST, Department of Science and Technology Nidhi Scheme, where you can actually get money. Then one big thing which has come, where the total budget is 100,000 crores is their total budget, and they have hardly been able to spend about 50 crores. It has to be spent in 2 years, and actually they will get it back. And this is the Anusandhan National Research Foundation of Department of Science and Technology. Please go to their website, and they're continuously grants are coming. And they have just come out with a research development innovation grant, where not only the scientists and engineers, but the industry partners can also seek funds. So that means it will help in upscaling industry partners and take it forward. You have Indian Council for Medical Research collaborating centers of excellence. You have ICMR research program for early career seed grant. You have ICMR electronic project management systems for your electronic data. Yeah. And then you have ignition grant. So therefore, having done all this, so 30 years I've been a neurosurgeon. I have done more than 8,000 to 9,000 surgeries, and complex ones, not those simple ventricular shunt and gliomas, no, very complex one. I have trained more than 120 students who are now every Institute of National Importance, AIMS, NIMHANS, SDPGI, Sri Chitra, everyone, professors, many of them, the head of the department of PGI will be at some point trained. Then, so the important thing is to try new things and take yourself to the next level. And don't just stick to what you were doing. You have to experiment. And therefore, what are the conclusions which I would like to draw? The first conclusion is that real discoveries only take place when people of diverse backgrounds, looking at things from their own perspective, work towards a common goal. This is teamwork. When you have a startup company, when your youngster has a startup company which you want to kind of nurture, please understand you have to tell that person, you cannot be an expert in everything. There will be people who will look at your business, somebody who will look at your design iteration, somebody will look at your engineering component, somebody will look at your biomaterial component, somebody will look at your electronic component. Do not think that you are capable of doing everything. But together, when you make a team, then magic happens. So people with diverse background, somebody said, seek out people who make you uncomfortable if you really want progress. The second very important thing is reverse engineering. In the engineering parlance, what does reverse engineering mean? Reverse engineering means that you take a machine, which is imported machine, then you break it up into its components, and then you build it up again. And in that, you learn technology. But my definition of a reverse engineering is completely different. My definition of reverse engineering is ask people of different backgrounds to come to your background, to come to your environment. Maybe an operation theater, maybe an ICU, maybe a ward. And because those people think differently, they will immediately come up with wonderful ideas which will actually completely improve your ecosystem. Like with IIT Kanpur, I had this young students, 23 years old, and I asked them to wash with me in my surgery. So this is a craniovertebral junction between the head and the spine, so I was doing the fixation. And he said, can I have a scale and a protractor? A scale and a protractor. And I said, why do you want a scale and a protractor here? So he measured all those things and we came up with a wonderful device which has been patented and now is at the translation readiness level 6 or 7. So like that, you have to reverse engineer your things. The third very important thing is, you respect this person because the person is pole dancing. But actually, you should not pole dance. What you have to do is have a stable foundation, like that rock at Mahabalipuram. You have to work with a stable foundation. You can't just say that, okay, I'm pole dancing. You have to have multiple things going on together. Just don't latch on to one idea and make it your passion. Just work with a broad background and that will give you the background and also give you the credibility to actually work with other things and to get more industry partners. Don't do pole dancing, have a stable foundation. The fourth very, very important thing is, we had this Miss World, we are all very proud of her. She's very pretty, but the girl there smiling is also equally pretty. But I have a question for all of you. Will you allow this girl dressed in these clothes to actually go in the Miss World competition? No. Likewise, when you in your labs make these small devices and one industry partner comes, they say, what is this? This is nothing. They don't understand the value of the device simply because it does not have a design component to it. I'll tell you a very interesting thing. Have you ever opened any electronic device equipment in your hospital? Have you ever opened it? Have you ever seen it from inside? You have not. Has anybody opened up a device and just seen it from inside? There are only 5-6 wires and the rest is empty space. Then why do they need such a big thing? Like you have this, they're exhibiting this now, what do you call it? You see this monitor. You open the monitor, everything is empty space. Okay? There are only a few wires running here and there. Most of it is integrated circuit which will be fitted into this much pocket. Why have they made such a big thing? Simply because you will not pay for it if they give you a small device like that. just to make sure that your thing is big. That's their design component. You can't blame them for it, and you don't know about it. You understand? So this is a very important thing. Prototype to product presentation is vital. You know, this, I had taken this picture, all these pictures I've taken myself, and this was taken in Udaipur, of course, as you know. But you see those birds there, they're not birds, they're bats, big bats. Okay, look like birds. You understand? So you see the design component is very, very important. So from a distance, they all look the same. Sorry. Then the next thing is, this is near Dull Lake. Now there's a beautiful book, Super Freakonomics. Now Freakonomics and Super Freakonomics are beautiful books. What they talk about is that in any environment that you go, you have to look at the financial aspect of it. If I'm taking a lecture here, it involves money. It involves my coming here. It involves my spending my time. It involves all of you spending your time. It involves air conditioning. It involves breakfast. It involves so many other people who are working. So it involves money. And this is one important aspect that you really need to look at. It has to be a time-bound thing, and every action that you do has to be translated into economics. That is something as doctors we don't understand. But an industry person who's losing money by the hour immediately understands. So please learn their language. Freakonomics is extremely important. The sixth, this is from my own apartment. This is Sunset. So quality ensures longevity. What happens is that if you don't work on quality, one device will come and then it will wither away because it doesn't have that quality. So if you really want a product to continue for some time, you have to ensure with patience that it gives you absolute quality. And finally, I've spent a long time in Japan, and I was doing neurosurgery there. And each Japanese person or those people in Japan will identify with me when they say that each of them has a hobby. So somebody is doing this bonsai, somebody is doing kenda. Kenda is playing with fighting with those sticks. Somebody is doing judo, and somebody is doing this Japanese tea ceremony. There's a group of people who all their life will just try to make a perfect circle with a brush of stroke. Whole life. They have clubs making enzos. Enzos are perfect circles without lifting up your brush. I said, what are you doing? What is the significance of this? Making circles on papers. And they said, no, there is a thought behind it. The first thing is when you start making an enzo, you don't know where it will lead to. Just go on making it. One day, it will be a perfect enzo in your own perception. Go on making it. The second important point he said was very interesting. He said that when you look at any one point in that enzo, you don't know where that enzo will actually lead to, but you still make it. You understand? So from that point, please make your own enzos, which may not be conforming to other people's view of how conventional life should be. The other important point which happens with all of us intellectuals is over-analysis leads to paralysis. We go on analyzing rather than saying, okay, let's do it. We just go on analyzing. Once we do it, there is a path to it. When you go on analyzing, if this happens and this will happen, this happens, this will happen, nothing happens. You just don't start. So over-analysis leads to paralysis. You just have to say, okay, I'm doing it. We just do it, and then suddenly, the path clears by itself. That's the second point. The third very important thing is perfection is a focus. It's not a target. You can never achieve perfection. As soon as you reach a point which you think is perfection, your goalpost moves away. You become a director, then you say, oh, I need to do this. Then I need to retire peacefully. That becomes your goalpost. You understand? So your goalpost keeps shifting, and it's never perfection. Then the most important thing, which in every medical college this is a problem, equanimity in adversity is a strength. So your emotional quotient, your ability to keep calm in the presence of adversity, your ability to understand that at any given point of life, something will always go wrong. Okay, that's a very important strength. Sorry, can I have sound on this? So, sound? Can you stop it again and play it again? Just go to the previous slide. So this is from the movie Pocahontas, and so this is sung by Vanessa Williams in Walt Disney production Pocahontas. उसका sound आ जाएगा? हाँ, ये आ नहीं रहा sound. वो तेज कर देना. So एक बार फिर से वापस जाना और जब मैं बोलूं तब स्टार्ट करना. हाँ. So this won the Academy Award for the best motion picture, best lyrics, okay, best filming, best editing. So this is Walt Disney Pocahontas. Please can play करो उसको.
Must be so, but still I cannot see if the savage one is me. How can there be so much that you don't know?
एक मिनट stop करना. So here a Spanish conquistador comes from Europe and he's killing all animals. He's fallen in love with Pocahontas, who's from South America, and Pocahontas gives him a lesson of life. Please go ahead.
Have you ever heard the folk cry to the moon or ask the great bobcat why he grinned? Can you sing with all the voices of the mountain? Can you paint with all the colors of the wind? Can you paint with all the colors of the wind? Brainstorm and the river are my brothers. Heron and the otter are my friends. But we are all connected to each other in a circle, in a hoop that never ends. Even the sycamore grow. If you cut it down, then you'll never know. And you'll never hear the wolf cry to the blue corn moon. For whether we are white or copper-skinned, we need to sing with all the voices of the mountain. We need to paint with all the colors of the wind. You can own the earth and still all you'll own is earth until you can paint with all the colors of the wind.
Next slide. So I came back from an operation theater one day, and I just saw this web here, and I just took a photograph. I was too tired, went off to sleep. Then I just took it on my laptop the next day, and to my surprise, I saw that spider at the end of that web. So it was a complete surprise for me, and this became a very special photograph because of that spider at the end of the web. So just to take some words from that song, you think the only people who act and think like you. But if you walk the footsteps of a stranger, You will learn things you never knew you never knew. The second important is we are all connected to each other by a circle, a hoop that never ends. So we think we are all separate from each other. It's not like that. We are all connected to each other. And the third is very important. You can own Earth, but still all you will own is Earth until you can paint with all the colors of the wind. Next slide, please. So I was in Visakhapatnam and I was concentrating on these black boats here. And I took this picture, went home, and then saw it on a larger screen. And then to my surprise, I found that big ship behind, hidden in the fog. So when we are only focusing on this boat, which is our patients, and this thing, and this is our patient, this is your patient, and this will happen, and this will happen, we're only focusing on this boat. But there is a huge ship behind which is hidden in the fog, which we can actually access, and we have no idea that it exists there. So please focus on the ship also. Thank you so much for this honor and privilege.
A big round of applause for Dr. Bihari, everyone. And it's a great reminder, sir, that all the questions that we are always hesitant to ask are the ones that we need to ask first. And sir, you are a great photographer. I think we all can definitely agree upon that. I welcome Sanjeev Mittalji, Senior Advisor BFI, to kindly felicitate Dr. Bihari as a token of our appreciation. Thank you. So here's the thing about innovation. It's not one lightning bolt idea, it's layer. It's a stack. So layer by layer, every ecosystem, every person has to give their own experiences, insights, and learning. And to break down that for us, I invite Dr. Sanchita Chaudhary, Program Director BFI Nama, to talk about what BFI Innovation Full Stack is all about. Dr. Sanchita, over to you.
Good morning, everyone. I hope I'm audible to all. Thank you. So I don't need to start with an introduction of BFI. I understand everybody is in one way or the other connected to us, is our partner. And I would like to talk about the thesis of BFI in terms of what we are looking at currently and what we are working with you all for. So BFI, as you know, is a catalytic ecosystem enabler promoting biomedical research and innovation in India. And we started with translational COVID relief. Then we moved into translational research, creating a network and ecosystem across multiple institutions, incubators, organizations, startups, innovators in India. And 8 months back, we delved into a very ambitious flagship initiative we call as Innovation Full Stack. Many of you are part of that ecosystem under the Medical College Incubation Center program. So this is an orientation program for medical college incubation centers, but for this session I'm going to zoom out a bit and tell you the overarching vision of BFI in terms of IFS, so that you are able to understand how important and crucial a role you all play and how close we need to work with across multiple programs so that we are able to deliver the impact that we have embarked on in the journey. So this looks like a complex slide, but just to give a perspective, many of you know that we have supported research institutions for translational research across India. We have supported technology business incubators and innovators and startups through the technology business incubators to work on, path-breaking innovations, having trust in those innovators so that a pipeline is created. We have supported medical colleges under multiple programs of BIOME, BFI BIOME, the first program, and many of the clinicians are and have worked on translational research under many of these programs. The public health framework is a parallel track since COVID relief, which is a public health vertical, and BFI in its core mandate has the public health objective at the bottom of everything, and that is a parallel vertical which works for us. And market access I'm going to come on because this is a new aspect we have added under Innovation Full Stack. So as I just mentioned, the first two category of stakeholders have been supported under BFI BIOME, the first program. The medical colleges have been supported under another vertical of BFI BIOME. We call it as SAMAT. Dr. Sonalika, who is steering this event, is the nodal officer. If you want to know more about it, you can connect with her and understand. The public health vertical works under the name of a program called District Full Stack. And market access we are coming to as we speak. So now when I say 8 months back we embarked on this flagship initiative of Innovation Full Stack, we tried to bring together all our expertise, all our learnings, all our ecosystem network together to be able to deliver something impactful together. And that's how BFI Innovation Full Stack, took shape. I need you to go back 8 slides each. So what we have tried to do is that the pipeline that has been created earlier, we have tried to channelize it in a focused approach so that we can focus on path-breaking innovations, selected innovations which actually have the potential to create impact, and take them through a very well-curated pathway of technology readiness levels towards market. That is the end objective. Most of you would know that technologies have readiness levels. Dr. Sanjay Bihari also talked about technology readiness levels from 1 to 9. 1 being the initial proof of ideation and 9 being a market product. So when we say that we start with BFI BIOME, which is TRL1, so the ideation has already there, the pipeline is created. Under BFI Innovation Full Stack, we have 4 programs you see in the bottom panel. The first one we call BFI Namaha. Namaha is Nailwal MedTech Acceleration Hub. The place you are sitting is one of the acceleration hubs of BFI. IIT Delhi has been supported by BFI for being an accelerator for medical devices, implants, in vitro diagnostics. So what is the role of this program? The role of this program is to accelerate medical devices, technologies for in vitro diagnostics through technology readiness levels 2 to 6 or 7 or 8. So what it essentially means is we are trying to de-risk your early technology development to take you to a level where you can enter the next phase of your development, which is medical college incubation centers. Please note that this actually draws from the network that has been already created by supporting medical colleges under the SAMAT program. The third is the district full stack. So we will come to a district sandbox for that, real world implementation, and the market access is an actual market-driven program for product promotion supporting your products in market. Can you go to the next slide, please? This is another complex slide, I do understand. But to bring what I have been saying, bring my point home, what I want to say here in the left panel is that you see all the stages of technology development. And you see on the right what BFI provides under the programs that I mentioned. Essentially, each and every step of each and every technology readiness level is being catered to under one program or the other. And the right flowchart shows that all these programs and all these stages are interlinked with each other. So whichever stage of the technology readiness level you are in any part of the country, you will have access to the ecosystem that BFI provides, and based on your merit, if you have already applied to one or more of the programs, your applications would be granted or maybe under review or would be reviewed in due course of time. So that is what this shows. I will briefly talk about each of these 4 programs that I talked about for you to understand that where you are and how you can leverage these programs. Next, please. The first, as I mentioned, is NAMA. So we have a NAMA program at a center called M Pragati Center, which is supported by ICMR DHR. We have all our experts, mentors of M Pragati NAMA program sitting right behind you. So if you want to interact for the infrastructure facilities available, I will say the last, I think, 2 round tables have the senior staff and experts who are engineers and design experts, AI experts who work on medical devices and develop them. So when I say NAMA hub, it's a hub wherein you come in, you get the expertise in terms of infrastructure, expertise in terms of manpower, expertise when I say manpower, it's not only engineering expertise, it's expertise beyond that. You will get regulatory support expertise. You know, for medical devices, you need ISO 13485, and there are, many other categories in terms of, diagnostics and others. You have those facilities here. You will have clean room, which you need for packaging and, final products. You will have regulatory experts who will help you understand which are the regulatory forms you need to fill up and in which stage you need to fill them and apply to CDSCO or relevant authorities. So this is a hub where you come, you work with them and get all your, stages clarified, discuss, understand, work with them as extended team members of experts and other associated vendors and partners. And the technical expertise provided by the faculty here is also a part of this NAMA hub. So you see the number of faculty. Professor Ashwini Agarwal showed the length and breadth of the departments and faculty. So they are all onboarded as mentors on lead basis. So you will have access to them as and when it may be required. Next, please. So today under NAMA program we have 3 hubs. IIT Delhi is one where we are. The other 2, one of them is in the western region of the country, Venture Center Pune. It's again an incubator, approximately 20-year-old incubator, which is the entrepreneurship wing of the CSIR Institute NCL Pune. The third one is IKP Knowledge Park. IKP Knowledge Park needs no introduction. It has been the first and pioneering knowledge park. They are spread across both Hyderabad and Bangalore. Bangalore is essentially the hub and the incubator for medical technologies. Dr. Satya Prakash Dash is the CEO of IKP. If you have any questions about the facilities and all, you may please reach out to him here. Can I move to the next one? I talked about the hubs. We say it's a hub and spoke system in our innovation full stack. So you all are the spokes which complete our hub and spoke model and the expertise. Because when these products get developed in the hubs and get the regulatory compliance test licenses, they need to go to you and access the patients through you to get the necessary validation needed to understand whether their devices, products, technologies work or not. That initial testing is very crucial. Startups do not have easy access to clinicians, them being very busy and engaged in a very different ecosystem of treating people and understanding the health issues. So you as the medical college incubation centers will provide the necessary platform, ecosystem, gateway to enable that, provide that ecosystem within the medical colleges where one, any clinician who has an innovation can work, understand, and try to look at the entrepreneurial aspect of it, developing a product. Second, any innovator who has a developed product with a test license can come to you and request for a clinical validation, where you connect them to the relevant clinicians, help them get their ethical clearances, and help them carry on their validation studies, taking the technologies further in the TRL journeys. So, I mean, I don't need to tell you, this is your forte that you essentially help from idea to clinical use. You work with you will be working with clinicians because you form the interface for the innovators. You will ensure prototyping to commercialization for those technologies that come through you. You will have access to the NAMA hubs that I talked about and the entire ecosystem of BFI as and when you reach out for the necessary support. And definitely from the clinical settings, the clinical workflows, there is a continuous innovation pipeline, because that is where the problem statements originate. The engineers who build outside would not understand, they would just read something and understand this is a problem, but clinicians are actually facing it each day. So they are the right people to understand where is the need, where is the gap, and where the innovations are needed to be generated. Next, please. So this is just a summary of what I said in the previous slide. So essentially, you form a very critical clinical link to the technologies which are developed and need to actually reach the patients or the human masses that you treat. Next, please. So as we speak, we just completed the hub and spoke model. These are, I mean, all you experts, all you incubators who have already become a part of our ecosystem under hub and spoke. In the center, you see BFI NAMA. It can be any of the NAMA hubs, or it can be a combination of NAMA hubs depending on the kind of expertise you are required to be connected with. So that is the channel that you will have open all the time. Next, please. The third one, once a product is clinically validated, it's just clinically validated, but we don't know how well it fits into the clinical workflows, public health workflows, clinical ecosystem, and how is it user friendly? Will it be used in the primary health centers by people? Is it too difficult? It is just another added burden for them to use another device or an app in addition to the existing systems. So this is what will be tested under district sandbox, whether there is a public health fit to your technology. Next, please. So essentially, as mentioned here in the 4 bullets, after the clinical validation, you will be able to go to these sandbox which are in different districts. Under the 3rd program, district sandbox, you will be able to actually do pilot deployments and field testing. You will be able to generate data. You will be able to get the data you need for convincing the key opinion leaders, for getting publications, for being able to penetrate deeper with your product into the clinical usage ecosystem. Definitely ethics and regulatory guidance are a part and parcel of it. If you are able to enter the system, that means you have followed those critical pathways and you have crossed those hurdles to reach out to the patients who need your device. And definitely you would have hospital based validation pathways, because there is a network of local medical administration that you work with, the PHCs, CHCs, there are district hospitals. Depending on which district you are talking about, the needs will be different, the pathways will be different, the focus areas will be different. So this definitely provides access to the local government medical ecosystem, which otherwise is difficult for you to access. Next, please. So last, but probably for innovators, the most important is the market. I mean, once they spend so many years toil with so many grants, funds, etc., if the product does not reach the market, does not give you return for investment, everything is a waste for the innovator. It may be a path-breaking product, but if people are not able to use it, it just stays in patents, publications, and probably examples to show in such presentations. It doesn't help. So when we were building the IFS, it was understood that it doesn't get completed till the product is sold in the market. And the organization is able to sustain making those and selling to larger number of people. So that is when product promotion vertical came into existence. It is essentially a marketing arm that the selected products who have already crossed the previous hurdles and reached a stage where they can just, make more products and reach the masses, but do not have the necessary sales or marketing experience. This vertical provides you the extended team members as marketing professionals who will be your, voices to take your product, to talk to the key opinion leaders, to help you distribute, enable distribution, access distribution networks. Next, please. So these are the key points that the product promotion vertical will enable you to do. Getting early market feedback, because they will help you place your products at relevant places where you get user feedback. It will enable you to create a market by talking to key opinion leaders, convincing them. It will help distributor enablement. It will also help you get write the public tenders in the right way so that the chances of winning are more. So essentially, it's like your team is expanded to have marketing and sales people without actually embarking into hiring them. Being a part of this program, being selected, will mean these benefits for you. Next, please. So when I complete this entire innovation full stack pathway, I started right from ideation and I end in actual market sales of a product. So all steps are covered in between, or the enablement and crosstalk between the multiple channels, multiple programs is proposed to be very seamless. As you all know, we had a call for application for 2 months from 1st June to 31st of July, and we have received an overwhelming response of the very high number of applications across all programs. So currently evaluations are taking place, and soon the assignments of innovations will be done through to multiple partners as assigned. And I mean, this is about IFS. So I hope you have engaging discussions, the medical college incubation centers, regarding all the programs and regarding how your role will play on when you start working on these. So that's all I have to speak right now. Thank you so much for your time and your patient hearing. I look forward to interacting with all of you. Thank you. There is a small video which summarizes, less than 2-minute video, which summarizes all that I spoke about.
To some of healthcare's most pressing challenges. However, many of these ideas never progress beyond the lab. There is a need. India is home to exceptional scientific talent and world-class biomedical research. Across laboratories and research institutions, innovators are developing promising solutions to some of healthcare's most pressing challenges. However, many of these ideas never progress beyond the lab. There is a need for an end-to-end platform that provides product development and prototyping labs, clinician access and validation, regulatory and compliance pathways, mentorship, testing and deployment, commercialization, market access and scale-up. BFI Innovation Full Stack is built to bridge this gap through its programs designed to support every stage of biomedical innovation. BFI Nama helps an innovator transform an idea into a working prototype and a working prototype into a finished medical product through pilot manufacturing, regulatory pathways, and clinical validation. Medical college incubation centers help convert a finished product into a clinically validated product by providing innovator with clinician access, medical mentorship, and guidance through ethics approvals. District Sandbox helps a startup convert a clinically tested product into a field-tested product through pilot deployment, workflow validation, and evidence generation. The product promotion program helps founders convert a field-tested product into a market-ready product through market validation, doctor outreach, and distribution partnerships. If you're building something that can improve healthcare, this is your opportunity to be part of that change. Join the BFI Innovation Full Stack and help build the future of biomedical innovation in India. India is home to exceptional scientific talent and world-class.
Hi, good afternoon. Good morning actually. I'm Dr. Monis Mirza. I'm the head of the Department Hospital Administration and Names Patenda. I just wanted to have a small comment. First of all, wonderful presentation and wonderful program, yeah, and I'm really happy to be the part of it. There's one elephant in the room which we usually don't talk about, and we assume that this is right, that the doctors prefer international equipments more than the Indian. There was one study which I was going through, that is about the post-market surveillance of the indigenous devices manufactured in India. In terms of the medical device adverse events, 97% of the reviews or the comments were from the basically market authorization holders, and less than 3% comments were or the feedback system is from the actual users. So just by assuming something, we have to have a proper reporting system to the end users. If 97% of the adverse events are being reported by the manufacturers and only 3% are reported by the actual users, then there will be a presumption that the doctors don't use it. Let us give them the voice by which the actual development takes place.
So I'll just cite one more example, quoting your point only. In COVID times, I was working in a medical college and I was had the department of procurement also. And we all know that at that time ventilators were hard to get. And before that, we never compromised on anything else rather than the big names, the big companies that we have. But during COVID times, actually, we were forced to take some of the indigenous companies like Bell and Shaurya. And then we realized that Shaurya ventilators were actually as good as the GE ones that we had. So I think apart from what you said, there is also a very big mindset of going for forensics in medical colleges and these doctors, and we cannot deny it. हम क्वालिटी से थोड़ा सा कॉम्प्रोमाइज करने के डर से हम इंडियन को अडॉप्ट नहीं करते हैं, बट इफ यू डू यूज इट, दिस इज अ वेरी प्राइम एग्जांपल, दिस बेल वेंटिलेटर एंड शोर वेंटिलेटर which are now present throughout the length and breadth of this country at half the cost. So similarly, we can also promote indigenous product. We use them. If there are quality issues, definitely they will not survive. But at least we should give them a chance first to in the market itself. Thank you.
Thank you for the question and thank you, Dr. Gaurav.
So I think I completely relate to what you're saying, and also because at AIIMS Delhi also we have we face similar kind of issues. Many of the people just take it for granted that most of the doctors, they prefer some of the international equipments. But on the contrary, when we have seen within the faculty, being a part of those faculty associations also, the faculties even at AIIMS Delhi are very much interested in looking into these kind of programs. And even the question was coming to my mind to sort of look into how AIIMS Bhatinda has also sort of initiated this BFI Nama, because these are some of the areas which are actually the need. Because if we are looking into co-developing of some of the indigenous microscopes, and I know certain faculties who are interested in developing certain equipments which are being imported, just to name it, as like small scissors, which are also imported from Japan, which can be actually indigenously made. So maybe some these kind of innovation hubs we can maybe learn from AIIMS Bhatinda, how they went about it, and also take your support and how we can initiate at AIIMS Delhi as well. Yeah, thank you.
Thank you, Dr. Deepika, for the example from AIIMS Delhi, and thank you, Dr. Sanchita, for taking all the layers so beautifully. Moving on, it's my absolute pleasure to call upon the stage someone who needs no introduction, Sandeep Nailwal, founder, Blockchain for Impact, and CEO of Polygon Foundation, who brings his passion in everything he does. Sandeep, may I invite you to talk about the experience and the vision?
Hello. Yeah. Hello, everyone. Good morning, and I am Sandeep. As the team mentioned, that I happen to be the
the guy who originally, brought in the money, and Dr. Gaurav, मुझे लगता है बार बार ये मेरी बेइज्जती कराने के लिए मुझे बुलाते रहते हैं, क्योंकि ये बहुत अच्छा काम कर रहे हैं और ये मुझे बुलाते रहते हैं कि बताओ मैं क्या क्या कर रहा हूँ, ठीक है, बाकी लोगों को. So I basically, like, the kind of people are there in the room. I have no stature to tell you any of the things, but maybe maximum I can share my thoughts that whatever high level decisions I am taking with Dr. Gaurav and other leadership members of BFI, that what's the intent behind it. And I think we have already said this multiple times also, but I can repeat a little bit about that, is that when we started BFI, it was an emergency relief fund that we created for the Delta wave of COVID. And we did a lot of emergency relief work for quite some time. And we realized that we can keep doing it, but we cannot have, this will not bring a long lasting impact to India, right? And that's when I think 24 types where we started this quest of what can we do which can bring long term impact, which can change the ground reality a little bit, instead of we doing some small contribution in the daily running of the country in some forms. And that's where we started pivoting our the work that we do from the emergency relief to the translational research and development in the country. And even more than that, I, coming from a startup background and having done some things with my startup, and especially in the area of changing the financial infrastructure that Polygon works on, my learning has been that if you really want to have an impact on the society, and it's a little bit counterintuitive, and especially I would say against the Indian cultural roots, that if you want to bring impact in the society, you should work for commercial outcomes. Like, if you do work for doing the impact, your impact will be much smaller. Instead, if you do work to build commercial outcome, and if you have the good intent, eventually you will be able to bring much more impact in the society than the people who are only working for the impact. And that's the intent, for the core intent at whatever we do with BFI. You will see the core intent would be to enable people to drive commercial outcomes. Like, so that's why we are focused on startups. कि आप startups, as a startup आप जाओ, आप नए products बनाओ, इंडिया में indigenous products बनाओ, business build करो. ये नहीं कि भाई मैंने ये प्रोडक्ट बनाया, मैंने ये रिसर्च पेपर पब्लिश कर दिया, ये पेटेंट बना दिया, वो हमारे लिए थोड़ा कम फोकस और काइंड ऑफ प्रायोरिटी एरिया है. द प्रायोरिटी एरिया इज कि तुम कुछ बनाओ एंड उससे बड़ी कंपनी बिल्ड करो, और उसको इतना बड़ा बनाओ कि देन यू हैव मनी टू अगेन कीप फंडिंग बैक द इम्पैक्ट पार्ट्स इन इंडिया. एंड आई थिंक वो हमारा, आई थिंक कल्चरली ऑल्सो, वी इंडियंस, like, again, you will take it with a pinch of salt what I'm going to say, but culturally we hate money, right? And you will say कि नहीं यार, इंडिया में भी देखो कितना करप्शन भी है, ये भी है, तो इंडिया में पैसों से लोगों को बहुत प्यार है. वो बात सही है, बट एज अ सिविलाइजेशन, आप हमारी जो स्क्रिप्चर्स पढ़ोगे, रामायण महाभारत, और जो भी हमें स्पिरिचुअलिटी में भी सिखाया जाता है, वो ये है कि त्याग करना है आपको, एंड में ये कुछ मैटर नहीं करता. इवेंचुअली इवन कुछ लोग बिजनेस में पैसा कमाते भी हैं, इवेंचुअली उनका इंटेंट ये होता है कि यार ये पैसे से मुझे दूर जाना है, और कितना पैसा कमा लोगे आप एक टाइम में. सबके अंदर एक डीप डाउन ये भाव रहता होगा. आई थिंक मेरे अंदर रहता है, तो मुझे लगता है बहुत सारे लोगों में रहता है कि ठीक है यार, अगर तुमने थोड़े पैसे कमा लिए, ऑफ कोर्स इट कम्स आफ्टर सम, इफ यू हैव मेड सम मनी, इट डजंट, लाइक बिल गेट्स सेड ना कि मनी कांट बाय यू हैप्पीनेस, but you need to have enough money to say that, right? So वो एक important part है. तो एक बेस होना चाहिए, लेकिन उसके बाद हमारे जो कल्चरल रूट्स हैं, वो सब लोग डीप डाउन मनी से हेट करते हैं. ये एक सबकॉन्शियस पार्ट है. मतलब मैं साइकेट्री में अगर आप डीप जाओगे तो मुझे लगता है कुछ लोग समझ पाएंगे इस बात को कि कल्चरली वी हेट दैट पार्ट. एंड उसकी वजह से क्या होता है कि स्पेशली जो हमारे सीनियर लीडरशिप है, वो एक टाइम के बाद ना मनी रिलेटेड चीजों में कम इंटरेक्ट करना चाहती है। हमारी गवर्नमेंट की पॉलिसीज भी वैसी हैं, हमने ऐसे सिस्टम बना रखे हैं कि हमारे जो इफ आई एम नॉट रॉन्ग, हमारे जो सिविल ब्यूरोक्रेट्स हैं उनको हम अवार्ड भी नहीं दे सकते, राइट? अब कुछ ऐसा फंडा आ रहा था कि उनको हम अवार्ड या कुछ हम उनको स्कॉलरशिप नहीं दे सकते बिकॉज गवर्नमेंट एम्प्लॉयज को अलाउड नहीं है मनी एक्सेप्ट करना और ये सब चीजें, राइट? तो वो अगेन आपको एक डीप रूटेड सिस्टम बताता है। अगर आप यूएस में जाओगे बहुत डिफरेंट है। यूएस में बहुत सारी बड़ी बड़ी कंपनियां एस्टैब्लिश जो लोग करते हैं वो जनरली प्रोफेसर्स एस्टैब्लिश कर रहे होते हैं या रिसर्चर्स एस्टैब्लिश कर रहे होते हैं जो कि वेरी क्लोज टू द एक्चुअल कटिंग एज रिसर्च के अराउंड होते हैं। लेकिन हमारे यहाँ सिस्टम ऐसा बना हुआ है कि इट्स रियली हार्ड टू डू, और इवन इफ इट्स नॉट हार्ड टू डू, जहां पे सिस्टम चेंज भी हो रहा है, आई थिंक कि डीप डाउन इट्स लुक डाउन अपॉन। जैसे इंडिया में आप ये मान लो कि इफ एनीबडी मेक्स मनी, 90% ऑफ द पीपल ऑलरेडी थिंक कि यार इसने पैसा बनाया कुछ चोरी करके ही बनाया होगा। इंडिया में कॉन्सेप्ट ही है कि जो भी अमीर आदमी है हमारे ऑटोमेटिकली दिमाग में आता है कि ये कुछ तो चोरी करता होगा पीछे, राइट? तो वो अगेन एक डीप कल्चरल रूट है हम सबके अंदर। और जैसे हमारे आप उसकी बात भी कर रहे थे, अगेन हमारा इंफीरियोरिटी कॉम्प्लेक्स भी है, जो आप बोल रहे थे ना कि भाई इंडियन प्रोडक्ट्स को यार डॉक्टर्स ही यूज नहीं करना चाहते हमारे इंडियन डॉक्टर्स, राइट? वो डीप डाउन वो सेम इंफीरियोरिटी कॉम्प्लेक्स है जो कि हमें दिखता है कि यहाँ पे हमारे इंडिया में कोई या अगर आपको बाहर से कोई अंग्रेज आता है और वो चाहे तो वो यूएस में बैठ के, मान लो फोटोग्राफर है, वो यूएस में बैठ के हो सकता है शादी की वीडियो बनाता हो, शादी की रील बनाता हो, लेकिन यहाँ पे आके वो अगर यार ये कुछ अलग ही फोटो खींचता है यार ये, राइट? हमारे यहाँ पे जो क्रिएटिव आर्टिस्ट भी होगा उसको हमें लगेगा कि यार ये तो वो मजा नहीं है इसमें, राइट? तो ये हमारा डीप रूटेड कल्चरल वो ये इतनी जल्दी चेंज होगा नहीं। इसमें आपने क्वेश्चन पूछा, लोगों ने आंसर भी दिया, चेंज नहीं होगा इसमें, बहुत इतनी जल्दी नहीं होगा, इसको 20 साल 30 साल लगेंगे हमें, बिकॉज वी इंडिया विल बिकम ए इंडस्ट्रियलाइज्ड कंट्री और हमारे कुछ 2-4 ब्रांड बड़े होंगे होपफुली। मतलब हम सोच रहे हैं, मैं भी 10 साल से सोच रहा हूँ कि कुछ ऐसा होगा। मैं पॉलीगॉन में भी मैंने यही कोशिश करी है कि मैं इंडिया से एक ग्लोबल ब्रांड बनाऊं, तो और ग्लोबल लार्जेस्ट ऑफ द लार्जेस्ट बैंक्स और कंपनीज यूज करें उसे हमारे प्रोडक्ट को, तो उससे एक फीलिंग आएगी यार इंडिया से भी बन सकती हैं ऐसी कंपनीज और ऐसे प्रोडक्ट्स। बट वो इतनी जल्दी चेंज नहीं होगा। उसके लिए चाहिए होगा कि हमारी कुछ कंपनीज बहुत हाई क्वालिटी प्रोडक्ट बनाएं और फिर हाँ हाँ, मतलब वो इंटरनली भी है कि क्वालिटी कॉम्प्रोमाइज करके प्रॉफिट, क्योंकि यहाँ पे मार्जिन इतने कम है। इंडिया में सबसे बड़ी प्रॉब्लम है कि अगर आप अच्छा काम कर रहे हो आपको मार्जिन देने नहीं चाहता कोई भी, है ना? करेक्ट।
Hello, I am Dr. Anil Goyal. I am Professor Head of Radiation Oncology in AIIMS Bathinda. So we use the international linear accelerators for our precision treatment in oncology. So we have Indian-made linear accelerators also from Panacea in collaboration with the Atomic Energy Regulatory Board (AERB). But there is a difference in the quality. So basically, that has not been either they have used some, I don't know, they have compromised their quality because they want to make easy money. So
नहीं इजी, मैं आपसे कहूंगा कि इजी मनी तो है एक पार्ट, पर बिजनेस चलाने वाला ना सबको समझ में आता है ये बात कि यार मैं अगर अच्छा प्रोडक्ट बेचूंगा तो मुझे लॉन्ग टर्म कॉन्ट्रैक्ट मिलेंगे, बड़े कॉन्ट्रैक्ट मिलेंगे। बट प्रॉब्लम है कि जो बायर भी है ना, क्योंकि ऑब्वियसली हमारे पास उतना पैसा नहीं रहा है ट्रेडिशनली एज अ कंट्री, तो हम जो खरीदने वाला है वो भी सस्ता माल खरीदना चाहता है। मैं आपको जो ट्रैवल एक्सपीरियंस कराने वाली कंपनी होती है ना, कि जो आपको, चलो हम आपको एक बड़ा छोटा एग्जांपल है मेडिकल, आप तो बहुत टेक्निकल बातें कर रहे हैं, मैं तो कह रहा हूं कि अगर आपको एक ट्रैवल एजेंसी है जो आपको बोलती है कि मैं आपको हिमालय में लेके जाऊंगा, हिमाचल प्रदेश में यहाँ ट्रिप कराएंगे, सब कुछ कराएंगे, और वो बड़ा एक्सपीरियंस कितना भी काम करें वो, और वो आपसे बोलें कि आपको इस पैकेज के 50,000 रुपए लगेंगे, हमारा इमीडिएटली ध्यान जाता है यार ये 4 चीजें करा रहा है, इतने की बस की टिकट बुक करूंगा, इतने की होऊंगा, ये तो यार 35,000 रुपए का 15,000 रुपए खा रहा है बीच में, राइट? हमारा थॉट प्रोसेस ये है, हम देना ही नहीं चाहते क्वालिटी के लिए, वी डोंट वांट टू पे फॉर क्वालिटी। एंड अगेन वो किसी का ब्लेम नहीं है उसमें, किसी इंडिविजुअल के लिए। Sorry, it's not like that. First, the government procurements we have to understand. It is through the general financial rules of the 2017.
So sorry, we will be breaking for tea shortly after this. So I request you all to engage with him.
अच्छा, ये मैं लेट हो गया कि लंबा बोल दिया क्या मैंने? ओहो, ये मैं ये कह रहा हूँ, देखो मेरे पास एक्चुअल मुद्दे के लिए मेरे पास ज्यादा, मैं आपके सामने एम्स के प्रोफेसर है, मैं क्या बोलूँ मेडिकल साइंस के बारे में, तो लेकिन हाँ मतलब एनीवेज तो मैं क्विकली कंक्लूड करता हूँ. तो जो MCIC हमारा प्रोग्राम है वो भी एक यही अटेम्प्ट है कि हम कॉलेजेस के क्लोज जाके जहाँ पे दिस लाइक हॉर्सेस माउथ, लाइक लिस्टिंग फ्रॉम द हॉर्सेस माउथ. तो जो डॉक्टर्स हैं दे आर एबल टू सी in their live patients and the students there, and students have like this mindset of ki, what can we do new, right? So probably this will inspire some of the youngsters in these medical colleges who are studying, who see the live problems in their patients lives, and they can solve some problems. That's the simple goal about it. This is actually one of the most exciting programs for me, right? Because this actually goes to the grassroots, and this can get a lot of people connected. But for BFI, what we are doing is we are trying to stitch this whole ये जो problem segment है startups को market में आने के लिए, कि जो researcher and innovator है उसके पास वो links और connects नहीं है to go to the hospitals and get clinical validation and what not, and फिर उसके बाद funding and marketing और वो सब कुछ चीजें. तो we are trying to combine and bring like one single platform where you can go from TRL1 to TRL10, right? So that's the goal, right? TRL10 as in like go to market and then post go to market things. So that's why. So my thought process is any decision I take is I take those decisions from the point of view is can somebody build a big business, big commercial outcome from this or not? Because according to me, that is the only thing that will change India. So because or spiritually, अच्छा मैं 2 minute और लेता हूँ, right? Spiritually also, ये अगर if some of the people like senior people जो maybe I'm like now 38, 39 and getting into the midlife crisis and all those things, so we start thinking कि spiritually we all want to go inside, right? And मैंने ये सोचा कि यार how can I combine these two things, because there's always this dichotomy as a startup founder, especially for the startup founders I'm telling you there, that as a dichotomy कि यार मैं ये क्यों इतनी मेहनत कर रहा हूँ मैं ये सब काम करके, इससे अच्छा मैं कई बार सोचता हूँ कि यार 2 महीने की छुट्टी लेके मोनेस्ट्री में चले जाता हूँ कहीं, वहाँ बैठ के मेडिटेट करता हूँ, ये सब कुछ करता हूँ. बट आई वॉन्ट अ डीपर आंसर टू माई सेल्फ कि वाई एम आई डूइंग दिस. एंड उसका आंसर मुझे स्पिरिचुअलिटी में ये मिला है कि हमारे कल्चर में स्पिरिचुअलिटी 2 तरीके से आप पा सकते हो. इनफैक्ट 3-4 तरीके हैं. ज्ञान योग, कर्म, उसमें कर्म योग भी एक तरीका है टू फाइंड salvation, right? So I am looking for that कि जो सिंपल लॉजिक है कि या तो आप जो क्वांटम फिजिक्स में भी या तो आप ऑब्जर्वेबल यूनिवर्स को पूरे को अंडरस्टैंड कर लो, और या फिर आप प्लैंक लेंथ पे जाके वहां तक सब कुछ अंदर जाके अंडरस्टैंड कर लो. इन बोथ केसेस यू कैन गेट द निर्वाणा, राइट? सो आई एम फॉर मी द स्पिरिचुअल आंसर इज कि मैं बाहर की दुनिया को समझने के लिए कर रहा हूँ. आई फील लाइक इलॉन मस्क इज अ वेरी बिग स्पिरिचुअल पर्सन इन दैट. ही वांट्स टू अंडरस्टैंड मोर एंड मोर ऑफ द यूनिवर्स, एंड उसके लिए ये सारी चीजें कर रहा है. आपको लगता है यार इतनी बड़ी कंपनी बना दी, ये कर दी, वो कर दी, बट डीप डाउन ही इज सिंपली ट्राइंग टू फाइंड आंसर. ही इज इन द सर्च ऑफ द अल्टीमेट क्वेश्चन. सो फॉर ऑल द सीनियर पीपल हियर, व्हाई दे शुड हेल्प द स्टार्टअप्स, एंड मैं इसलिए बोल रहा हूँ ये बात, इसलिए स्पिरिचुअलिटी में इसलिए नहीं बोल रहा, पर मैं इसलिए आई वांट यू गाइस टू एंगेज विद द स्टार्टअप्स, हेल्प देम. डोंट डिस्पाइज कि ये कोई यार कमर्शियल आउटकम के लिए काम कर रहा है. You help them to build big businesses, which will help them to spend more money to understand more things outside. So in a way, you are also working towards your own eventual, goal of life or spiritual goals and all that. And that's why, like the senior leadership professors especially should be engaging with startups is my request and call to action for all the professors here. So thank you. I'm sorry, मैं ज़्यादा बोल दिया.
May I request Dr. Satya to come up here to felicitate Sandeep as a token of our appreciation.
ये मैं आपको डॉक्टर गौरव, आप मुझे मतलब, पर मुझे ये फेलिसिटेशन वगैरह जो है ये मैं जानता हूँ गवर्नमेंट इंस्टीट्यूट्स के लिए बढ़िया, पर स्टार्टअप वाले बंदों में ये शॉल वॉल पहनाना फन नहीं है, बट इट्स नॉट कूल. BFI should work as a, मैं बोलूँगा कि non-profit startup. देखो सर्दियाँ आ रही हैं. God bless you.
Thank you, Sandeep. Thank you, Satya sir. So we will now take a 15-minute short break. I'll request everyone to please have the tea which is being served on the right side back of this room. And we'll reconvene by 12:15 here again. Hi everyone. I request that everyone please come back to your seats. We'll start in next 1 minute.
Rajesh, Sagar, Rajesh.
Everyone, you can please continue your coffee and teas on the table.
Cross the T's and dot the I's. When you say that, it's not about that chai. Dr. Anand Bhan, Dr. Anand Bhan, Faraj, आइए आगे. Okay. Otherwise, we're running late because the incoming flight was late, so I'm not to be blamed. That's how things are. Okay.
Thank
upload
you,
yours.
Dr. Satya. So I hope the coffee, sandwiches, and that brownie did its job. And we have heard about the questions and innovation full stack layer by layer and everything. So
You know, whenever you come to the panel, it's always about kissa kursi ki. So can't bad right. Moderator. We're 45 minutes, and I'm not going to introduce anybody because I think all of you know them. If you don't, then please Google them or find them on LinkedIn. They have some fabulous, I mean, collectively, perhaps more than I think 80 years amongst us. So that's the experience, or maybe close to 100 years. Anyway, this is a small group, and I have lots of amazing leadership here, friends here. I see Dr. Tony Raj, Dr. Anand Phan. I know they know lots of depth in this. And we were thinking, so how does and you know, an idea come into a practical product, and then product is in the market? Is that the end of the journey? The answer is no. And what happens from the idea to the product to the market, and then what? And what are the turbulences that a startup founder uh, has to deal with while she or he is making that product? And let me just do a poll here. How many clinicians are here, including on the dais? Okay, so there is around 5 or 6. How many run incubators? Okay, 2, 3, that's good. Suman Gupta is here. She runs one wonderful incubator here in Faridabad. Okay, and other scientists, chemists, whatever you want to call yourself? Anybody? Yeah, a few, right. Those who proudly use doctor but actually aren't the real ones. But so, so that's the whole idea, and I want to keep it conversational. So please chime in, raise your hands. You know that
you want to ask any idea question that you have. There is a concept called, these are some phrases that you will keep on hearing, and I've been hearing this for the last 20 years, called value of death. How many of you know that? Okay, that's good. I don't want to reflect on that. But essentially, the team here, we have a clinician who also, has over the last 20 years has seen public health, has done COVID response, and as well as, looked at technology, both from medtech, software side, and now currently is building one of the largest medtech programs for government of Karnataka. We have a true blue entrepreneur, PhD from IIT Bombay, and then carried forward his PhD thesis to build a product again, it's a cutting edge product, now being on the ground, at least 200,000 families, 500,000? 1 million families. So here is one product that is right there helping on the ground would-be moms. Right? And we have Dr. Sanchita. Sanchita, she carries the ecosystem. She has seen the ecosystem from its nascent days until today. And I'm moderating this. My name is Satya Dash. One of the couple of questions, and why I'm not fumbling because you're not prepared. But because it's such a vast question in the next 20 minutes, Dr. Sweta mentioned that, so we don't know where to start, what is the anchor? So let's start with this. I made some notes by asking Gemini, I'm sorry. Very truthful here. But forget it, I'm not going to look at it. Each of the stage at a startup thinks about, and we want to contextualize it for the medical incubation that Dr. Sweta Jindal is doing that, right? Is how does that idea, that nebulous idea, take shape and then finally reaches the market? And it's very easy to be thinking very linearly, but it's not linear, right? So my first question, I said I won't look at cheat sheets, but he said NEET ka exam hai, so I'm going to do that. Okay, what's the first biggest misconception that startups have when they are building a product? Misconception during early stage, misconception during middle stages, and misconception when they are in the market. Okay, let's start with that. And I will begin, obviously, with Sanchita Chaudhary here. I said obviously, you know that. But you can take my mic. Okay. Working? So misconceptions that startups do. Early stage, middle stage, and mature stage of product.
Sure, thank you, Dr. Satya, for this question. Early stage is definitely, what I am doing is the greatest thing on this earth without contextualizing it with the need of the society or need of the ecosystem I'm looking at. Here in this forum, it's about the clinical unmet need or the gap that they are solving. If they're doing something as part of their thesis or engineering that they feel is the greatest thing on this earth, without relating it to the clinical need, this is early stage. Mid stage, definitely for medical technologies, it's the regulations. Complete lack of knowledge of regulatory requirements depending on what products there are, and therefore they go the complete length of development and then start thinking that they have to keep coming back and reiterating and lose a lot of time. In market, definitely they don't look at the market fit in the clinical workflows, healthcare workflows. So essentially, I mean, that is a complete black box for most of the innovators. Still they are, until they are part of the clinical ecosystem, which is what is being tried in this medical college incubation center program.
Okay, great. Three things he said, and this is to all those who want to run medical incubation, who are interacting with medical incubators, right? And very succinctly put by Sanchita here. Let's move to Dr. Bhaskar, whom we lovingly call Bhaskar. It reminds me of the movie Anand. You know. Go ahead.
Thank you. So at all three stages,